Hello, we're going to have a quick look at some area this afternoon so that you can use that to help you in this topic coming up. We're going to be doing lots of geometry and area is a really key topic. Some of these things you'll already know and some of them perhaps you won't have come across previously. So it's important that we have a look at both so that you can see where you're going with it. Okay, first things first. The area of a square or rectangle, and this is definitely one that you've already dealt with many times right since primary school, so I don't need to worry too much. It's easier to remember this if you think of it as base times height. Okay, all your key vocabulary is listed at the side of the screen here, so if you need to, by all means pause it, get it written down in your green books and make sure you've got the spellings correct from there. But base and height, and we're all quite happy that to do this and to find the area of these things, we'd do the base times the height. So if we had a base of 4 and a height of 5, we would do 4 times 5, giving us 20, and in this case it's units squared, because I haven't mentioned whether it's centimetres or metres or kilometres or whatever. Okay, so base times height for the area of a square or a rectangle. When it comes to triangles, and this is why it makes it easier to have dealt with the base and the height on the rectangle, is because when we deal with triangles, you can see this triangle is very roughly half of the rectangle above. And so if that had a base of 4 and a height of 5 as well, you can see that we're missing half of the rectangle. So to find the area of a triangle, we do half of the base times the height, which in this case is half of 4 times 5, giving us 10 units squared. There is another way to find the area of a triangle, and I'm going to give you the formula so that you've got it, because you will be using it in some of the work that you're going to do. It's based on trigonometry, and I know that some of you find trig a little bit tricky, but in this case I want you to just take it down as a formula, work on it, have a little practice at substituting in the values during the work you do today, and you should be okay. All right, don't worry about it. When we're back in class, I will go through why it works and how it works in a bit more detail another time. But for today, just think about it as either half of base times height, or the other formula, which is half of A times B sine C. Okay? Just use it. Don't panic about it. That should actually be a capital C. Half of A times B times sine C, with a capital C because it's the angle. Okay? The A and the B are sides. For a parallelogram, I've actually got a manipulative for you here, a special bit of paper that I prepared earlier in true Blue Peter style. So, parallelogram. Hopefully you can see that that's very clear and that is 2 parallel sides, top and bottom, and another pair left and right. And the lovely thing about a parallelogram is that if you cut it in exactly the right place, as I'm doing just now, you can see very clearly and very quickly that the area of a parallelogram should be exactly the same as the formula for the area of a rectangle or square, because a parallelogram with one end cut off and stuck on the other side is just a rectangle. Okay, so by squaring that off, by cutting that so it's perpendicular, base and height, you can see that the area of a parallelogram is exactly the same formula as the area of a rectangle, that is base times the perpendicular height. Perpendicular, remember, means at right angles to, doesn't it? So base, just here, times the height, and that's this height here, not what we call the slant height of the parallelogram. So it's the base times the perpendicular height just there. Okay, that height at right angles, not rectangles. Sorry. For a trapezium, now I've drawn a bigger diagram for this one because the area of a trapezium, if you put 2 trapezia, 1 trapezium, 2 trapezia, if you put two trapezia together, can you see that this length here, if we call that length A, let's call that length just here A as well, and this length here is B, that length there is B as well. So I've got a trapezium and I've turned it over the other way and stuck it next to it, so I end up with two trapezia. They've both got the same perpendicular height, you can see that, can't you? So we have here two congruent, meaning exactly the same shape, exactly the same size trapezia. I've got those two trapezia that are congruent, they're the same shape. I've taken one and turned it over and made it again. All of a sudden, the outside of that shape, you can see, if I draw it nice and quickly, is a parallelogram. And just like for a triangle, half of a rectangle gives us a triangle. If we've got a trapezium, we can see that that's half of a parallelogram. So we want half of the base times the height, because the parallelogram is base times height and the trapezia is going to be half of that. So just to get the area of this trapezia, this one here, let's do it in green so you can see which one I'm talking about. Just to get the area of that bit, we're going to need half of the whole parallelogram, and that whole parallelogram would be the base times the height. So this green trapezium is going to be half of the total base times the perpendicular height, which means that it becomes half of A add B times the height. And you'll notice and remember that A and B are there. So I might draw it out again to try and make it a little clearer for you. If I have just one trapezium, it's not very clear, is it? If I have just one trapezium, my formula, and I'm going to call the top A and the bottom B, and the distance between them H, my formula is half of the base and the top times the distance between them. Okay, half of A plus B times H. Hopefully you'll find that useful. Okay, don't forget, if you need it, key vocabularies down the side here. Have a great day.